Good afternoon, everybody. This is PROG 39599 Advanced Java Frameworks, or Java 4 for those in the know. Your humble proctor, Simon Hood, and I am simon.hood at SheridanCollege.ca if you need me. Gosh, I have a great lecture in store for folks. I hope at least it's a great lecture. I have lots of engaging and interesting bits. And I will talk too much if you let me, so I'm going to try to keep a lid on my stories and my factoids for you, but I do have some interesting ones that I hope you will enjoy baked in to today. Before we get to that, however, somebody tell me, refresh our memories, what did we talk about last time? Where were we last week?
We were using the annotation in one-to-one.
Yeah, Nabil, I can always count on you. Amazing. 1-to-1, correct, for 250 points. Amazing. Oops, Azra got logged out. There we go.
We did joins last week, I believe, right, sir? I think like something similar to joins. I remember.
Correct, Jeremy and Nabil. Yeah, 1-to-1 is a way to relate different entities together, such that one entity has an instance, of another instance. One entity knows about is another way you could put it, but has is really the correct verb. One entity has an instance of something else. A projector has a power cord. A student has an address. A cell phone has a SIM card. 1-to-1, right? 1-to-1. One thing has one other thing. Awesome. If you get 1-to-1 and you'd like to know more, which is hopefully everybody, I have a great lecture, I hope it works out for you today, which is the continuation of it. Moving past 1-to-1, a single thing to relate to a single other thing, into 1-to-many. A one-to-many relationship. The primary purpose of today's lecture, not one thing to one other thing, or like 1-to-1, rather one to lots of some other thing. Lots of different things. What would be a good example? A school has not one student, but many students. A program has not one course, but many courses. One thing related to many of something else, some undeterminate number. Awesome. Along the way, and it came up, I think it was last class it came up, somebody asked me about cascade types and fetch types, and they're in here, and they were always in here today. This class, you folks are sharp. You're slightly ahead of the curve at most times. So whoever asked me for that, thank you. It's in today, a little bit at least. I'm going to try to make it a little bit clearer if I can. And we're going to round out today, which is a reasonable length lecture, depending on how long I'm chatting, with something called many-to-many. And I'm not going to demo many-to-many. It's almost identical to one-to-many, except obviously there's more on the other side too. Many things can be related to many things. But as far as Java is concerned, it's basically the same. We'll talk about it. You can play with it if you want. We'll make it go. All right, so awesome. We saw 1-to-1 last class, which is one thing related to exactly one instance of something else. But there are at least two other major hibernate relationships we can use. If we ever find ourselves in a situation on our ER diagram or in our storage or however we're doing this, whatever we require for our application, where we need one entity related to, a bunch of other entities, a collection of other entities, if you will, well, then we can use one-to-many and massively simplify our lives. And sometimes, not often, but sometimes, some rare times, we find ourselves in a situation where many entities can be related to many other entities, which is like the worst case scenario. It's at that point, it's just getting complicated. It's sort of hard to wrap your head around it. I don't even have a lot of good examples of many-to-many. It's less common. Unless you're talking bidirectional, where like this side's related to this one and this side's related to this one. It's up to you. There are ways to make these things work, and if your ER diagram specifies that, that's how you do it. But it's more rare. Easily accomplished with many-to-many, but more rare. There's not much more to explain beyond that. We'll talk a little bit about cascade and fetch types, but I want to jump into some code. I want to show you more than I tell you about one-to-many. Copying lecture 32 into lecture 41, one-to-many. We got this. Lecture 41, many. My fingers are cold. My chair is squeaky. My fingers are cold. I may have trouble typing today. Also, we're going to do an example today with vehicles, and for whatever reason, my muscle memory does not ever want to type the word vehicle correctly spelled. If I misspell it accidentally, someone please tell me, catch me on it. I know how to spell it, but for whatever reason, it's just my fingers don't type it the way I intend to spell it. Okay, so we might now, we had an example last class where Paul McCartney, if you recall, has an account. So we have a student bean where we're storing individual students, an instance of a student, their ID, their name, and an account. Awesome, easy. And we have a second entity for each student. So each student has one account, a second entity account with an ID, an account number, and a balance, as well as some notes, which are of type lob, so like any really length that you wish that field to be, and an account status. And our account status, finishing off last class's lecture, is an enum. It is not anything like you could type, but rather one of a specific small set of possible choices. In this case, the status is open, under review, approved, or rejected. Okay, we get this. Paul McCartney has an account. Paul McCartney is the world's single richest rock star, the richest rock star that has ever lived, richest musician that has ever lived. I think I can say that correctly. No one has ever made more money from the music than Paul McCartney, ever. And he does good things in the world. I don't want to talk negatively about anyone, really. Billionaires is one thing. He's a billionaire, but 100 billion, I don't know, whatever. He does try to do a lot of charitable work, so we're letting him slide. Okay. We might say Paul McCartney, our Paul McCartney, the Paul McCartney, Sir Paul McCartney, has a vehicle. He has a car. Paul McCartney has a car. But, given that he's a $1.2 billion heir, if I can say that, it's a pretty safe bet he has more than one car. More than one. I would bet a lot of money that he drives 10, 15 cars. Who knows? What are you going to spend your money on other than charitable works? So, we're going to set up a relationship with Paul McCartney's cars. I think we can do this. And we're going to say, just in brief, Paul McCartney owns more than one. Let's start with the car, with the vehicle. We're going to make a Peugeot vehicle. Let's start there. First, we got to describe a car. We need to store information about cars. And another new class, carefully typing, named vehicle. In vehicle, a private, private long ID, private string name, private big decimal price. Is that what I had in mind? Something like that. ID, string name, big decimal price. Yeah. The ID number, the name of the car, like the car, whatever you want to call it, model, if you will, and a big decimal price. Easy. Awesome. All right. Lombok. Because we can. Type. Because Lombok is so magical. I'm going to add a builder on this one too. Lombok, our main for Lombok annotations. And then, entity. Also telling Spring Data JPA we want this thing to be a database table. And I better save this. And then at ID. And I want my ID to be a generated value column following a strategy equal to generation type of identity. Whew, I don't know whether my auto import will bring all this stuff in without crashing. Ah, got it. Great. And we got like that. We got a vehicle. We have a vehicle table now where we can store all different kinds of vehicles. Whatever you need to know. Add properties, remove properties. Lombok makes it easy. With our vehicle POJO or entity, we also need a vehicle repository. Seems sort of obvious at this point. I want to be able to work with vehicles. So, okay. Another interface. Naming it there's a typo. Vehicle repository. And I need to extend JPA repository while I'm at it. Easy. Wrap this thing around a vehicle. And the ID type in our vehicle POJO is long. The type of the ID column in our vehicle is long. Yes, verified. Confirmed. Great. Vehicle repository. So easy. No time at all, really, to set this stuff up. Now, in our controller and Bootstrap data class, we need, obviously to inject an instance of our vehicle repository. If I could type it without punching the keyboard too much. One for our controller. And by the way, because I have an all args constructor here, I don't have a lot of auto-wired individual things. They'll all be injected. Everything I add to this controller will be injected. And same thing with my Bootstrap data, as far as I know. Yes. Because there's no alternative for Spring. It has to inject. There's no other way to build these things. Nice. Like a plan. It comes together. Easy, awesome, easy. Easy peasy. Okay, so we got a vehicle repository injected into our our controller, and our Bootstrap data. Now, keeping it interesting if I can, if you'll permit me, if you'll humor me. Paul McCartney sings a line in a song. I think it's actually the name of the song as well. Baby, you can drive my car. Say I if you know how that is sung. Baby, you can... Anybody? I, one person? Desiree? Couple people? Baby, you can drive my car. Dun, 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 dun. You know you're gonna be a star. Dun, 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 dun. Baby, I'm terrible saying that. Baby, you can be... That's like, damn, you got it. Baby, you can drive my car. And baby, I love you. Beep, 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 yeah. It's immortal lyrics. Exceptionally catchy. Thank you, Desiree. Some of the catchiest music that has ever been written. And it's at least 50 or 60 years old at this point. Maybe 70 years old. 1960 something, I think. And it's as timeless as the day it was written. Baby, you can drive my car. I have a question for folks. And I don't honestly know the answer. But I think it's an interesting question all the same. Yeah, beep, beep. It's like, I don't know about that. Someone said it may not have aged well. Perhaps. When I was learning to drive, I had a driving instructor who used to tell me to give people a toot. And honk my horn at pedestrians. And, I don't know that was so, really kind either. I don't know. Definitely, you don't want to sort of... Men in the room, you don't want to be honking at women or walking down the street near you. Don't do that stuff. Obviously, I don't need to go there, but... I hope I don't need to go there, but, let's leave that out of it. When Paul McCartney wrote and sang the immortal lines, Baby, you can drive my car, something or another, did it actually mean something? What's Paul McCartney's car? And I am curious. I have too much time on my hands. And so I looked it up. I Googled it. I wanted to know, what kind of car was he talking about when he said, baby, you could drive my car? And I was stunned, floored. It turned, it's like too busy looking up dates and times. It turns out, at roughly the time Paul McCartney wrote, or at least co-wrote, the song of Baby You Could Drive My Car with John Lennon and George Harrison and Ringo Starr, at roughly that time, he was driving a 1967 Lamborghini 400 GT. And my head exploded. Bam! What? That's a nice car. What? In 1967, the Beatles were doing really well, even at that time. I don't think I would say they were billionaires, but they had money to spend on frivolous rock star lifestyles. There were only 247 Lamborghini 400 GTs made, to my understanding, having loosely Googled this, so don't quote me on this, but only 247 were ever made. And that one that Paul McCartney owned and drove at the time, was even rarer because it was constructed or converted to drive on the left-hand side of the road with a right-hand sort of driving wheel. So instead of the driver's side being on the left, like it is in Ontario, it's on the right in England, which I'm sure everyone knows. I don't need to say any more about that. Super rare Lamborghini from 1967. Worth, according to my research, which was sketchy at best, approximately $175,000 in 1967 dollars. That's a nice car. That's a really nice car. I wonder, like, does it come with like a gold engine? Like, what do you get for $175,000? Whoa! A lot of money for a car. Yeah, thank you, Dana. That's a lot of money to spend on a car. And like, you know, money at that point really has to be meaningless to you. But I don't know. Maybe it's part of the lifestyle. Probably it sells records. I don't know. I mean, you know, James Dean is a famous sort of actor who died in a race car. I think I could be wrong with this. And if James Dean, while he was alive, drove any particular motorcycle or a car or whatever, his fame makes the car famous. His fame made cars famous, motorcycles famous. Same thing with Paul McCartney. They were hot. They were like on fire. They were the it people in that decade and era. Here's the question, though. All that aside. If you had a $175,000 car, and I'm talking about you, like you people with me, all of us in this room, if you owned $175,000 worth of metal on four wheels, would you let someone you're just beginning to date drive it? What would you do with it? Would you let, baby, you can drive my car. Yeah, let's go for a spin. Seeing some no's. Would anyone say, if anyone would, I'm curious, would anyone let someone you just met, maybe at a club or something, drive your car, your Lamborghini? Anyone? I figured it would be nobody. I also would not, if it helps. That's craziness. Who knows what they could breathe on it wrong. Like a la Ferris Bueller. 170. Oh, there you go. $1.4 million car. Thank you. Adjusted for inflation in 2021 dollars. A $1.4 million car. Whoa. Anyway, I don't think anyone in their right mind would let someone they're just beginning to date drive their Lamborghini. Maybe. I certainly wouldn't. I mean, what if they stripped the gears or like didn't brake properly, clutched wrong, bumped a curb? Like anything could happen. Bumped another car. Didn't realize how much power they had. Stuff happens. Yeah, I see. So if you had the money of the Beatles, whichever, you hit a really interesting point there. Maybe if you had that kind of money, maybe you would. Maybe you wouldn't care. Maybe it's already disposable to you. Who knows? Which is again sort of gross and goes along with billionaire arguments. But anyway, too much money. Okay, so let us perhaps add Paul McCartney's 1967 Lamborghini 400 GT to our Bootstrap data. We're going to begin in the Bootstrap data, I guess, some real code, by creating an instance of a vehicle. I'm going to fix this. I don't know how it does that. Another new vehicle using the builder pattern named Lamborghini 400 GT and worth $175,000, or what was that, 1.4 million? 1.4 million in 2021 dollars. Whoa, it's a lot of money for a car. It's a car. It's a car. Like, it's not a house or I don't know what you could buy. Really, we talk about billionaires all the time, but like $1 million is a lot of money. It's a lot of money. You're set for a long time. You can win less than the lottery. Anyway, so okay, created an instance of Paul McCartney's Lamborghini 400 GT. Before I forget, something I should have done is save the student and account instances, as in like grab the saved instance when we saved those entities, those Pojo, grab the populated entity back from the database. In this case, what this means is grab the ID that was generated with it. Just adding account equals to my account repository save and student equals to my student repository save. It's a better practice, and that way you have it if you need it. Anyway, okay. I didn't want to forget that. So, $175,000 in 1967 dollars is obviously a lot of money to most people who are students and also most professors. That's a lot of people. A lot of money, sorry. Most people on Earth. $175,000 is a lot of money. More than I would say, something I would guess, I could be wrong with this, I would guess that's more money than 90 or 95% of the world's population makes it a year. Considerably more than probably 99%. I don't know that stat though. And this got me thinking. $175,000, it's nothing to Paul McCartney in 1967. Surely he drove other cars. And for that matter, as long as you're talking about other cars, maybe we want to go extreme again. Ever wondered what the most expensive car ever sold is? And again, I'm up late at night and I have too much time sometimes. I don't have a lot of other things to do sometimes. I Googled that too. The Ferrari 250 GT, and there's different answers out there, but the Ferrari 250 GT seems to be the best guess at the most expensive car. There's lots of sites that say that one is the single most expensive one. There are some that are valued at more. Some that, so 48 million, I know. But Al-Qassam or whoever that was, 48 million was the highest auction price. But I think there was one that was sold for 70 million. Puke. 70 million? Are you serious? Google Ferrari 250 GT and see what comes up. The single most expensive car, to my knowledge, ever sold. And there's some that are valued at more. Like, we have to be careful with this. There's different ways to measure this, right? You're talking like tens of millions of dollars for who knows what. The price is, the price is what you're willing to pay, honestly. And obviously at that point, money's no object. A Ferrari 250 GT, I believe, and I might be wrong about this, was sold for $70 million once. I could be wrong about this. The single most expensive car of them all. And I found some stuff this afternoon that said the Ferrari 250 GTO, of which are only a handful, are worth something like 140 million, but it's unverified. I don't think any of them have sold at that amount. And I also found the thing, I think, Alexander, that you said, which is the most expensive car ever sold at auction was 48 point something million. I don't know. I'm splitting the difference. 70 million. Doesn't even matter at that point. 70 million. This particular Ferrari 250 GT that was sold for 70 million is literally a race car. It's a street legal race car. and it's won races. And the thing that is perhaps most interesting about it, and also ugly and kind of, not ugly, dark, twisted, evil maybe is a word you could use, is that people have been murdered around it. It has a past. It has a history. It has a story. It's seen stuff. It's been places. It has a story, and that is what you're buying, essentially, with your $70 million. You're buying a street legal race car that's won races that people have died around, or perhaps for, and I don't want to dig any deeper on that. That's a big deal. I don't know what the value of a human life is. I think it's measured in something called a millimort. Really, literally, there is a value on human life. Millions of a mort. A mort being one human life. And you could go all kind of Fight Club on this and say, I don't want to touch that anyway. Let's not go there. $70 million for a car, 4 wheels, 2 doors, I imagine, some windows, and an engine. Oh, my jaw is falling off. $70 million. What do you do with a car that's worth $70 million? What do you do with it? And this is a seriously good question, and I'm asking you, all of you out there, what would you do if you had a $70 million car?
Sell it.
Yeah, the correct answer. That's amazing, Desiree. Thank you. Sell it. Yeah, if you're not going to sell it, assuming you wanted to hang on to it, you can't drive it. Forget about driving it. You can't drive that around the street. Someone could sneeze on it. A piece of dust could land on it. Never mind a stone taking a chip. Yeah, take photos. That's very funny. You could have people pose with it. For $70 million, it could be in a museum. Although they won't pay you a lot of money for it, but you could donate it, I suppose. If you can afford $70 million for a car, you could probably afford to build your own museum around it, right? $70 million is not a small price for something like the ROM in downtown Toronto. Unreal, an unbelievable amount of money for a car. There's people that have too much money in this world. I think it's safe to say too much. It's a weird thing to say. I don't think, the average person in this room would agree with me, perhaps. Maybe you do. Maybe you do. I don't know. Let me take a vote. Is there such a thing as too much money? Can a person have too much money? This is a double point question.
Oh, yeah.
You can have too much money? So
Absolutely.
a person can have, like they out there in the world. There are people in this world that have too much money. I think we agree? Is that fair? Say nay if you don't agree. Say aye if you agree, or yes. Say aye or yes if you agree. There are people in this world that literally have too much money.
Aye.
I
So then, the double point of this question, the two-pronged approach here, say aye if it's possible for you. All of you individually out there, for you, Jeremy, Desiree, Nabil, Dana, everyone else, Akasam, for you to have too much money. Because it's the same question.
Oh, yeah. Absolutely. Oh, yeah.
You have to think about this, right?
Yeah, maybe.
Maybe. It's a different kind of feeling when it's me. It's different. I'm broke.
I'm not there yet, but yeah.
I'm not there either. Thank you. It's different. It's a different question. When is too much? Anyway, subject of a future lecture, perhaps. Let us add this second vehicle, a Ferrari 250 GT, worth $70 million to our Bootstrap data, create an instance of it, and then also save both of these vehicles. Save both of these vehicles to our repositories. Through our repository, to our database. Apologies. Save them both to the database. Nice. Neat. It's honestly very easy. Really, basically effortless. Okay, so vehicles, 2 of them in mind, although add as many as you want. Let us now add a list of vehicles to our student instance so that Paul McCartney can store his collection of cars. And collection is a pun, and pun intended. Literally, a list is a type of collection, and collections probably are the easiest way to do this. I'm going to add a private list of type vehicle, like a list generic, wrapped around a vehicle or vehicle entity to our Pojo, or to our student Pojo. Where am I? Here I am. Paul McCartney has an ID and a name and an account and a collection of vehicles. A Java util list of vehicle Pojos. That's pretty easy so far. Okay, cool. I'm gonna save my files before I forget. And so that this works with Bootstrap data, with my Bootstrap data, mostly because I'm using the builder pattern, and this vehicle list isn't actually equal to anything here. It's just blank for now. It's a blank interface. I'm going to populate it in my student before I forget. So we're going to create a student named Paul McCartney who has a new array list wrapped around a vehicle for his list, for his collection, for his vehicle list collection. There are other ways to do this. There are lots of ways to do this. This is just the one I've chosen for now. Just easy enough for me. I think it'll work well for now. I'm going to populate the vehicle list property with an actual possible thing to store stuff inside, with an actual array list. Because otherwise it doesn't really mean much. It's an interface. It's just structure. Okay. Different ways to do that. And then also, while we're at it, perhaps in our Bootstrap data, we're going to add these lists, add these vehicles, to our list in our student. So our student has a vehicle list. I've created 2 vehicles, and I think I'm going to add them here maybe. And I'm going to get this wrong probably, by the way, class. It's a very specific order you need to do these operations in sometimes. I'm going to add to our student instance, says vehicle list. I'm going to get the list of vehicles out of the student and then add our vehicle Pojo instance to it. Get the vehicle list, add something to it. And because this is passed by reference, which hopefully everyone knows, it's just a memory location, same memory location either way, we can actually stuff stuff inside our student this way. Student, get the vehicle list out of it, and then add a vehicle to it, and it's still the vehicle list inside student. There's only really one of it. Neat. Nice. Clean. Okay. And at long last, we're now ready to create another entity relationship in student on this list of vehicles. I'm going to add our relationship, our entity relationship. This one is a one-to-many. One student has many vehicles. Or at least can have many vehicles. You don't have to have many. You can have 0 or 1 if you want as well, but option is there. Some number up to and including larger than 1. Neat. Cool. Easy. Honestly, easy. I may have to come back to this. I'll just mention it now, I guess. I really did struggle to find an easy order to save this in. It's kind of tricky sometimes, and you will probably all find this in your own work as well. You may need to play around. The trick to this is that our student entity, where's my Bootstrap? Here it is. Our student entity has vehicles and a vehicle list inside it. And those vehicles have IDs that are generated. And so we kind of have to save the vehicles to generate the IDs before we can insert them into the student. And also when we insert them into the student, they should have IDs generated. But there's different ways to do this. You could alternatively generate the ID for the student, and with that student's ID, insert some vehicles. There's different orders you can do this in, And I honestly don't have a good kind of easy answer as to which one is best. I usually play with it. I usually reorder things based on the error messages that I get to make sure that it is saving it in a method that makes sense to hibernate, is I guess the short answer. If hibernate gives you an error that a vehicle doesn't have an ID, save the vehicle first. If hibernate gives you an error that a student doesn't have an ID, save the student first and then add the vehicles after. Or who knows what. Different ways to do this. Okay. Whew. I think we've got this. I suggested to myself, add the vehicles to the student first. Yes. Then save the student to end the account. Then save the vehicles. I have suggested to myself this. Having done this and crashed it multiple times, I've suggested to myself this. Maybe an optimal ordering to do it in. Add the vehicles to the student, save the student, then save the vehicles. I have suggested that to me, although I do not know whether that is best or will even work. Alternatively, I have also found at times it's easier to add the vehicles to the student, then save the vehicles, then save the account and the student. I don't know. I don't have a good answer here yet. If someone figures it out, let me know. All right. I'm ready to try this, I think. Let's just see what this does. Let's see if it runs at all even. Right click, run as. Spring boot up. Come on. Loading my H2 console. Maybe. Whoa. Whoops. Crash. We got a crash. Unsaved transient instance. CA shared college vehicle. Okay. Confirmed. That is a good example of an error that sometimes occurs with this. So I have to save the vehicle first. Okay, so I'll save the vehicles before I save the student in, which makes a certain amount of sense because they're dependent POJO, they're inner POJO in a sense. Let's try this. Restart. Saving the vehicles first, then saving the student and the account. Does this work? Looked good. Looked like a clean load. H2. Test connection. Yes. So we have a student table. Remember this? Paul McCartney, sir. Okay. Paul McCartney has an account. Paul McCartney's account looks like this. With $1.2 billion sitting in it. That's a nice balance to see. Okay. And we have some vehicles that we know about. A Lamborghini 400 GT worth $175,1967. And a Ferrari 250 GT worth a staggering $70 million. Wow, there are our vehicles. And now, the amazing part. How are these related? Our vehicles have an ID of 1 and 2. Our student, our single student, has an ID of 1. And so if I look at student vehicle list, which was generated auto-magically, I didn't have to make this table, this mapping table, this join table, but generated for us. If we look at this table, we will see, yeah, check, yes, money. We see that the student with the ID of 1 owns the vehicle with the ID of 1, the student with the ID of 2, 1 owns the vehicle with the ID of 2. Paul McCartney owns both vehicles. OneToMany. Thank you, Jeremy. You got this. Amazing. Amazing, folks. Awesome. Easy peasy. The default. So last class we talked about join columns versus join, like mapping tables, right? Join tables, literally. The default for 1-to-1 is a join column, to my understanding. If you don't specify how you want the relationship to be stored, it will store it as a join column. It will modify your independent entity and add a column to it. which isn't wrong, but it's less good to my mind because I don't want to mess with my entities. I don't want to have extra stuff in there that I may or may not need. You can, with one-to-one, force it to use a join column if you wish. You can force it, and we did. A join table is what I'm trying to say earlier. You force to use a join table, and we did. You can and maybe should. It's up to you, though. Stick with ways that work is my official answer on that. One-to-many is the opposite. One-to-many defaults to a join table. If you don't specify how you want to store it, it'll store it in a join table because that makes the most sense. And then follow me on this because it's kind of weird. If you want, though, if you really are like hardcore and really strongly prefer join columns, you can store it as a join column, as an added column, but it's a bit weird how it works. The join column, if you force this one-to-many relationship into join column, is not in the student, but rather in the vehicle. Which is weird, but it follows third normal form. One student can own many vehicles. If we have the join column for many vehicles in student, we have to duplicate our student instances all the time. Whereas if we put it in the vehicle, you could add one student to many vehicles. Each vehicle could have an instance of one student. It's a little confusing, perhaps, and maybe counterintuitive. For the most part, you don't need to worry about it. I tell you just so your notes are complete and so that if it ever comes up, it's maybe helpful. So that you know what you're talking about, maybe on an interview or something. But, defaults are fine. Join tables are best. It's up to you to choose ways that work. Drew, can I explain that again? Yes. Default for one-to-one is a join column in the independent entity, in this case, the student. Yeah? One-to-one. Join column, default, inside the larger entity. Student, in this case. Student to account. You can switch it to a join table. Flip that. Default for one-to-many is a join table. Defaults to join table, and you can flip it manually to a join column, but if you do, it's like the reverse of one-to-one in that the join column in this case goes in vehicle, not in student. In this case, if you have one-to-many, the join column, if you care about such things, which you honestly, Drew, don't need to. You don't need to worry about it too much. But if you ever needed to, you could theoretically add a join column to your dependent entity, in this case, in the student-vehicle relationship to vehicle, right? To vehicle. You could. But don't worry about it too much, folks. You mostly don't need to think about it. I just want you to know that it's an option. Just it's available should the need ever arise. Someday, maybe you're thinking back, in a job somewhere. Simon said something about that. Thanks, Drew. Simon said something about this once. Maybe I can ask him. I'll ping him on LinkedIn and see what he says. Yeah, Xavier, awesome. Good. I'm glad this is happening in the database courses. Good. Cool. Okay. All right. Ordering and cross relationships with modify our data in the future. Maybe I made all this look easy. It is honestly kind of a pain to line up the bootstrap data and other sort of save operations in a way that will work with dependent and independent entities, and especially with collections in them. It's kind of a pain. There's lots of specific orders that can work, and even more that don't. And, long story short, this part of it, you may need to play with. You may need to save it in the correct order so that the inner stuff, the account is saved before the student in this case, and also the vehicles are saved before the student in this case, because the student wraps around them all. We can't save our student with our account inside it and our vehicle list inside it, is my understanding, unless we already know what the account and vehicle list IDs are. I don't know. Figure it out. Play with it at least. It's about the best I can do. So, okay. Phew. Maybe I made this look easy. Maybe it works out. Maybe you modify something later. Maybe you have to modify it in a bunch of places. Is there an easier way? Check this out. If we modify our data, and how to say this, because it is stored in multiple tables now, right? Like, so it's Paul McCartney, we know and love. Paul McCartney is a student, yes, for sure. Paul McCartney is a student, and here's his information. But we have evidence of Paul McCartney in our student account table. Here he is. And we have evidence of Paul McCartney in our student vehicle list. Here he is again. If we ever want to change something, or maybe like delete something in particular, but change something even, we theoretically need to change it already with just a couple of simple things stored. We need to already change it in multiple places. There are multiple tables with evidence of Paul McCartney here now, right? Weird, kind of interesting. We can, if we wish, do something called a cascade. And a cascade, it's a bit like a trigger. It will ripple operations through. It can change our student in this case, or change our student-vehicle relationship, and have it ripple through the rest of our system. I'm going to, and I'm sorry if this isn't clear, I'm going to change our one-to-many relationship from student to vehicle, one student, many vehicles. I'm going to change it slightly. I'm going to use a cascade type of all. Cascade equals cascade type dot all. Although there are other possibilities, detach, merge, persist, refresh, remove, Google if you're interested. There's more you can know. I'm going to cascade every possible type of operation on this vehicle list. Cascade them all. Cascade everything. All is just about guaranteed to work unless you have a valid reason for not using all. You insist on only cascading one type of operation as opposed to anything, everything. Use it carefully, use it wisely. If I've done this correctly, and there's no guarantees that I have, if I've done this correctly and then I delete Paul McCartney from our database, and sort of just to prove it to you, kind of a hypothetical thing because it doesn't really make any sense, but if I were to come along and say student repository.delete by ID, pass it the instance of Paul McCartney. If I were to do this, what did I get wrong there? Delete by ID? Delete all by ID? Huh. That's interesting. Let's try this. I thought it was delete by ID. That's really unusual. What am I getting wrong? Getting something wrong. Repository dot delete delete by ID. Oh, I know what I did wrong. Student dot, I have to get the ID out of the student, out of Paul McCartney. There we go. Delete by ID, pass it the ID, the generated ID from our save operation. We're going to use it to delete Paul McCartney. I don't know why you'd want to. Like, this is ridiculous, sort of, but I just trying to prove a point. Show you what happens if you have cascades set up, which honestly probably you want to. I'm going to restart this and hope that it works. Come on. Save. Let's see what it does. Remembering that Paul McCartney is in a bunch of places now. Paul McCartney exists in our student table, obviously. What's going on? H2, come on. Crash something. What did I get wrong here? Detached entity passed to persist. Um. What did I get wrong? Vehicle was past persist. How to do this? Maybe I can do it. I know. Maybe I'll do it from my controller and see if that makes it easier. Delete student. That's super helpful, Oxam. Thank you for that. I'll try that in a second too. Let's see if this does anything. Oh, I don't have a student. Ah, nuts. Yeah, let's not do that. I'll try your method, Oxam. Back to bootstrap data. Student repository.delete. Oh yeah, there you go. I think I'm gonna get the same error, but I'm gonna try it. Let's just try it. See what happens. Maybe. Restart. Come on. Same error. The error is that I'm trying to persist a vehicle. Did I save the cascade on vehicle? Yes, I did. So I should not be persisting it. What did I get wrong? Sorry, I missed something in chat. If someone had a good fix in the chat, let me know with the mic. Can you? Whoever that was. I missed it. Anybody? Help a poor professor out. I did say I was going to blow up a bunch of lectures. What did I get wrong here? Delete student. I could. Let's make sure this works first. Let's make sure it still works. Let's get everything in there. That didn't work either. Look at that. What's going on? Again, I did say it's strangely complex to get this stuff saved in the right order. And so maybe at this point I want to save the vehicles after the student. Maybe.
No, I think you need to save the vehicles before the students.
I agreed, Ezra, but check this out. I'm not sure. I have had to play with this for some time to get it in the right order in the past as well. Look at that. I don't know why that is, and I wish someone could tell me. I don't know. It is what it is. Anyway, suffice it to say, how to say this. If it helps you at all, check this out. It's right here. This is what I had to do to fix it. I wrote myself a note with a tag that says E because it's a bit weird. Anyway, we added a cascade to our one-to-many relationship, student on vehicle, and then we deleted the student. Agreed? Agreed. Check this out. In our H2 database, we deleted the student. Agreed? Agreed. Paul McCartney? Psh, gone. Confirmed. As expected. Paul McCartney's vehicle relationships? Gone. Psh, confirmed. As expected. And then here's an interesting one. The vehicles themselves. Check it out. Gone. Psh, erased. Along with Paul McCartney. When we erased Paul McCartney, we cascaded that delete operation. And so the things that Paul McCartney knew about, or had in this case is the correct word, were also deleted. Isn't that cool? everything about Paul McCartney was deleted. I don't know about account actually. Yeah, account survived. Account is not a cascaded operation. It's not a cascaded relationship. So our account survived, but the student account relationship was erased. Cool, right? Like, cool. That's really helpful and really handy. And obviously something to be wary of, to be careful of. Cascading operations are pretty powerful. You can, if you're not careful, delete all kinds of stuff. If you're not careful. If you have a need to like keep referential integrity, which is the correct term, I believe, in your database, as in like you don't want vehicles to exist if the student that owns them doesn't, or like vanishes for whatever reason, you can do that. Cascade all, done. Easy. And on the other hand, if you prefer to say, you know what, an account is a thing. Money just doesn't vanish if it doesn't, like, if it's no longer in Paul McCartney's name. That money doesn't disappear. Will go to his estate, perhaps. It'll go to his family and you know, whatever, in accordance with his will, let's say. Maybe that's an example, right? If you prefer that style, well, then you're good. Just don't cascade it, and it will stick around. The mapping will be kept up to date either way. And that's cool. That's really neat. Powerful stuff. Our one-to-many was cascaded, and so in accordance with the cascade, when we deleted the student, we deleted the vehicles. Nice. Yeah, I think I've said this already. Be careful with cascades. File it in your tool of arsenal. In your arsenal of tools, in your utility belt for like whipping out and using when you need it. Like the batarang, that kind of boomerang thing Batman shoots. I don't know, whatever they are. I'm going to remove this cascade operation in our student. I don't really want a cascade because I would definitely be able to give a $70 million car a home. You know, maybe I shouldn't say that. I don't know that I could afford the insurance on a $70 million car. I think the insurance per year on a $70 million car is probably more than I make in a year. Not that I'm complaining. But I could sell it for you. Like, the car doesn't disappear. And that's valuable stuff. People have already died around it. You know, I don't want to get greedy. I'm going to remove the cascade on our vehicle list relationship. And if I've done this correctly, I crashed my system again. I don't know what's going on there. I'm going to fix my bootstrap data, perhaps. Yeah, the ordering is important now because I don't fully understand it. If I comment this, let's see if that works. I think I need to move the vehicles up again. Maybe. Yep, I do. Moving the vehicles back up because I don't need them to persist beyond the student. There's something to be said for, like, what do you want to have left? What do you need to know about at the end? I don't know. Something about that anyway. I don't fully understand. Anyway, so we got this. Restarting one more time without our delete operation and our correct ordering, we hope, fingers crossed as they say, on our bootstrap data. Yeah, that worked. Good, no errors. Great, okay, awesome. That's cascades. Those are cascades. Also, for filing in your tool belt of tricks and techniques, another great thing you can know about. Fetch types. Fetch types. Maybe it's helpful for you. Maybe it's not. We talked about it last class, although I think it was off camera. I tell you this only really so your notes are complete. And maybe in the weird case that it is useful for you. In practice, you know, I've had trouble making it actually do anything. I think essentially it defaults to basically the perfect use of it. But if it's ever a question on an interview and or you can actually make it do what it's supposed to do, you'll know. Fetch types. 2 different ways to grab data from our database. Eager and lazy. Eager fetch type, lazy fetch type. Dana, yes you can. You can delete a student without a cascade. Yes, you can. You should be able to. You might have to reorder that stuff. I don't know how that's working exactly, but you should be able to delete a student without cascading. And the vehicles will stay, not disappear. The relationship will go, the mapping table, but the vehicles will still be there if you're not cascading that delete. Yes, Dina, good question. Where am I? Fetch type eager versus fetch type lazy. Particularly useful with these relationships. While we're retrieving a particular instance of something from our database, the fetch type we set or default to will determine how far down the relationship chains we want to go. How far do you want to travel? Into said instances, your student in this case says nested information. How much do you want to grab with your original query? Interesting. Oops, Anisha. Hey, Anisha. For what it's worth, 1-to-1 defaults to eager, and 1-to-many defaults to lazy. But what does this mean? 1-to-1 is going to be set to eager by default, and 1-to-many is going to be set to lazy by default. Although we can change it if we want. As an example, with our student account relationship, if I am grabbing the details of Paul McCartney, in particular for this example, probably I also want all his account details. The only reason I'm even talking about Paul McCartney is because I'm talking about his net worth. That's why he's here. That's why he showed up. He's the single richest rock star who's ever lived. That's why we're talking about it. Makes a certain amount of sense to grab his account balance while I'm grabbing his name. Who's the richest rock star and what are they worth? You can say that in a single query, essentially. We want to know all the details about Paul McCartney's account every time I ask about Paul McCartney in this example, in this application. And because Paul McCartney in this example only has one account, it's never likely to wreck our system or take 20 years to process the query. Probably. I mean, most of the time. It's never going to eat too much RAM either. There's probably not going to be that much more stuff. There's only ever going to be, according to our student relationship, the relationship is student on account, there's only ever going to be one account. We set up that 1-to-1. One student has one account. There's only ever going to be one. So maybe we don't care. Maybe we don't need to worry about it. We're only ever going to grab one account when we grab the student info, and so it's never going to be too painful. Hopefully, theoretically. The default on 1-to-1 is eager. Grab all the nested information in addition to the outer or parent information the first time you ask. Every time you ask. Grab it all. Take everything. Find out what you need to know. That's eager. Fetch type eager. Grab everything as fast as you can. Take it all. On the other hand, we might also, or we do also have a student-vehicle relationship where some student could potentially, like Paul McCartney owns 2 cars in our example, but we're not restricted to 2. Any number of them, right? Check this out. Jay Leno, one of the world's more famous car collectors, owns, last I checked, 286 vehicles. It's like a different vehicle almost every day of the year. That's a lot of cars and also motorcycles. That's a lot of stuff. I don't even know where you store that. You need like an airplane hangar to store 286 cars. That's a pretty big parking lot. He is one of the world's premier car collectors. He loves it. He has a lot of the greatest cars. Interesting. If you just wanted the talk show host name whose name begins with J's last name, what is the last name of the person whose first name begins with J? You probably, and stick with me, you probably also don't want to grab all the information, ripping it all down on 286 different kinds of cars. You probably don't need that. You don't need that much power. You can have it if you want, but if you just want to know the last name and it's in the student anyway, fetch type lazy. Just grab the student, work with the student. There are lots of vehicles there, yeah, and we'll grab them when and if we need them, but if you don't need them, just leave them be. We don't know how many there are. It could take a while. Could be a slow operation, taxing, expensive. So that's fetch type lazy. Just grab what you need, leave everything else up in the database until such time as you require it. As luck would have it, ladies and gentlemen, I have struggled for several years now to make this visible. I have never, ever been able to do it. I'm issuing a challenge to the rock stars in the room. Make this visible if you're interested. If you have time and you're curious, I want to see fetch type lazy manually specified on a one-to-many in action. I've never been able to make it visible. I know that it does it. I believe it does it. At least I believe it does it, but I've never been able to actually see it happen. I'll show you my best efforts in a second. The reason for this is that anytime we call the getter on the student, in this case's internal vehicle list, our Hibernate and JPA systems will automatically perform the rest of the initialization by themselves in the background. We don't really ever need to worry about it. Anytime if we get a student, how to say this? If we get an instance of a student, theoretically with a fetch type of lazy on one-to-many, we just grab Paul McCartney, his name and his ID number. And then later, at any point, if we say, and get Paul McCartney's vehicles, get his vehicle list, at that time, and that time only, are we supposed to will our system go out and grab the vehicle information too? And if you never need to grab it, if you never get the vehicle list, you should never grab it. You should just leave those vehicles alone. But there's virtually no way that I know of to check if the list in student is empty versus loaded without actually calling that getter. I have racked my brain. How can I get it to check it? How can I check if it's empty without getting it? There's no way that I'm aware of. There's no way. And I've tried. I've given this a lot of thought. If anyone can make this go, I'm happy to teach the class. And how to say this? I like to make people immortal if I can and mention their names in future semesters. If you can solve this, I will happily put your name in the slides for as long as I'm teaching this sort of set of information, this stuff. Other people who are famous have been baked in various other places, mostly in Java 3 now. This is a whole new set of lectures. So anyway, okay. There's no way to check if the vehicle list is empty without actually getting it for comparison. I can't figure out how to do this. I've given it a lot of thought, and my best guess is to dig into the JPA API. Maybe, and honestly, I couldn't make it work. Here's my best efforts. Set our one-to-many in the student, starting with a fetch type of lazy. And it's just like the cascade. Instead of cascading, we're going to fetch with a fetch type of lazy. Just really very, very similar. Oops, I got to comment that too. There we go. As easy as that. Set the fetch attribute of our one-to-many relationship to a fetch type of lazy. Okay. Getting it. Got it. Good. Now, in our controller, a controller and a bootstrap. I wonder where I'm doing this. We'll do it in the controller. Sure. I don't have a student in the controller, and so I'm going to run some particularly sneaky code. It's not sneaky. It was my best shot at this. Let's see. Somewhere up here. No students in here, right? None. Although I could do this in the bootstrap data as well. Long value of 1. Maybe we do it like this. Maybe this works. Maybe this doesn't. I don't know. Maybe I'm trying something different this time. We're going to use something called a persistence util. And you will never need to do this, by the way. It's just my best effort, so you know where I've been. Persistence util, which we're going to get from JavaX persistence, literally out of the JPA library itself. A persistence utility. Then we're going to use our student repository to find a student by their ID. Find the student, not the vehicle. Just find the student. The student with the ID of 1, which is Paul McCartney, last I checked. And then with the student, and just the student, because the fetch type is lazy, right? We're going to check using our persistence util is loaded. Is the vehicle list in our student loaded? Is it set to something? Good question. I don't have a good answer. This has never worked for me, but theoretically it should not be. I'm going to print out the value of that. Whatever is returned from our is loaded, which is, I believe, a Boolean. Let's find out for sure. It is, in fact, a Boolean. True or false? True or false? Is the vehicle list in our student loaded when we just find the student after we set the fetch type to lazy? The correct answer is false, according to everything I've ever known about the universe. And if this works, I'll be made a fool of, perhaps. Or maybe a genius. Who knows? Fine line. Let's see what happens. Relaunch this thing. It's never worked for me in the past. Maybe I finally figured something out. Fluked it. I'm going to load our page. Do good things. And now in our console, look at that. True. Here we are. It was loaded. I cannot for the life of me figure out how fetch type lazy can be made visible. I believe that it's doing what they told me it is. I believe them when they say if you have a fetch type lazy, you just grab the student in this case. You can leave their vehicles alone until you actually require them. But I've never been able to make it happen, ever. And so Al-Qassam and Nabil and Desiree and Jeremy and Matthew, if you see this, all of you out there, Jasleen and Dana, Azra, all of you, everyone in this classroom, if you can make this happen, please show me. I'm issuing a challenge. If you have time and you're bored or you're interested, try it. Let me know. So you can use that lazy. Maybe Alexander, maybe that's what I'm missing. Maybe. Lazy to me usually means related to injection rather than to like database operations. Fetch type lazy is not the same thing as at lazy. I could be wrong about that. Try it, Alexander. Try it. You let me know. I will immortalize your name in lectures in this next slide for time memorial. Anyway, okay. Enough said. I hope. Someone let me know if you figured that out. I would love to see that go. Maybe it works. It didn't. Either way, take it as read. It is real. And at least I take it as read. It is real and it is happening. We should have seen our lazy list was not loaded until we actually get it. At which point the process, the getting of that data happens in the background. When you get the vehicle list, it grabs that information from the database. If you set it to eager, I would have expected that is loaded call to be true for sure, even if I hadn't got the vehicle list yet, which I didn't, because eager tells JPA, grab it all. Bring down everything from the database, all as far as you can travel along these relationships. Get everything. Grab it all right at the beginning. We're eager to know. Visible or not, I only told you that so your notes are complete in case you stumble across it. In the rare situation where you require or need full loading ahead of time, or alternatively, if full loading is making for a massive performance hit on your application. If you have not 256 cars, but rather 220 million tweets for one user. Fetch type lazy. 220 million %, shall I say. Don't grab them all. It will take forever. So be careful with that. It exists for a reason, but it's rare. And the defaults are pretty much fine for everything we need anyway. One-to-many defaults to lazy. One-to-one defaults to eager. It really, 500 said Omar, it makes for performance. It really can slow stuff down depending on what you're storing. Okay, so awesome. An hour and 16 in. Last thing for today. And I think I'm just going to talk about it. In fact, I know I'm just going to talk about it rather than a final demo. We're just going to discuss it because it's nothing really any different. You've already seen it now. There's one-to-one relationships where one entity has one other entity. Looks like this on an ER diagram. 1.1. One-to-one relationship. One entity has one other entity. And then there's one-to-many, where one entity has many other entities, or knows about, has many others. Has is the correct term. Looks like this on an ER diagram. 1.star asterisk. Some number between 0 and infinity. And finally, folks, there's also, if you're interested, although it's rare, such a thing as a many-to-many relationship, where many entities have a relationship to many other entities. And it looks like this on an ER diagram. Star, star, asterisk to asterisk. Many things can know about many things, can have many things. It's a bit weird to describe. I don't have a good example of it, but it's a possibility. Many to many is essentially identical to one to many rather, except it actually requires that join table. That's the main difference. There's no way to do it with a join column. You have to use a join table. That's the main difference. With our join table properly annotated, however, it's all the rest the same. You could argue many students could own many vehicles in this case, and perhaps and that means that some vehicles are owned by multiple people, perhaps. Maybe as a class we get together, everyone chips in $2 or $3 million, and we all buy that $70 million Ferrari together. Say aye if you're in. I don't know. Maybe I'll let you do that for your graduation present. I'm just kidding around. Okay, maybe. I mean, it's a ridiculously amount of money for a car, but it's a theoretical possibility, right? Theoretically, you could have a group of investors who wish to purchase a $70 million car. You could have many people who own not just a $70 million car, but lots of expensive cars. Maybe it's a thing. Many people, as in like an investment group, could own many houses. A more realistic real world scenario. Maybe. Maybe that is an example of many right there. Anyway, with our join table properly annotated, the rest of it, you just put many to many on top, and the rest of it is taken care of all for you automatically by itself. Switch the annotation to many, add in a few more students that you save independently, right? Like independently, save student.save, student.save, student.save. And all the mapping over who shares these vehicles or buildings or houses, whatever it might be, is auto magic. Easy. Rare, but easy. Awesome. And word of the wise, try not to be confused because this is a little confusing. It doesn't necessarily mean you have to use a list of students. You could easily have a list of students in your Bootstrap data, for example, and dot save all or something like that. Save your collection of students in one operation. You could have save many students to your database in a single operation in your Bootstrap data, along with many vehicles that you'd already saved perhaps, and then have all the relationships lined up in between. Maybe. Yeah. And then, but yeah, how's this? It wouldn't be any different than what we've already done though. Basically, you still have to save the student and save the vehicle in some order. Independently. Okay. And then there's one other possibility, which is something called a bi-directional relationship. And this one is more intuitive, perhaps, for the many-to-many relationship, but also a bit weird. You could say many students can have many vehicles with a relationship many-to-many on a vehicle list in student. And if you are really getting good at this stuff and had a need, you could also say that opposite direction, not student to vehicle, but vehicle to student. Yeah, that's a relationship too, you could say. Maybe it's also going in the opposite direction. Yes, a student has a vehicle, but maybe the vehicle also has a student. Maybe. In which case, you could put a list of students inside your vehicle list as well, inside your vehicle Pojo as well, rather, and have the relationship go in both directions. You can do this. It's confusing. It will take time to wrap your head around, perhaps. I don't think you're ever going to need to do it in my class, in our class, but maybe it has meaning for you. Maybe it has use. Not any harder. For the purposes of many-to-many and bi-directional relationships, most of the time you're still working with individual Pojo. It's not any harder than one-to-one or one-to-many. You save the student instance, you save the vehicle instance, you relate them. In some order. Save, relate, save, usually actually. As far as Java is concerned, we're going to let Hibernate and JPA, we already let Hibernate and JPA sort out the mapping anyway. We don't worry about it very much. We don't need to. We've abstracted that part of our lives out of our to-do list. Very cool. Very cool. And so, folks, that's all I have to say about one-to-many and also many-to-many and cascade and fetch types. And so I hope, and also by way of wrap up, I hope you agree, I think probably you do, that Hibernate and JPA are really powerful when used in combination. There's power at your fingertips here. Shoot lightning bolts and things. There's power at your fingertips. JPA allows us to perform CRUD operations, create, retrieve, update, and delete, on data in a database so easily. It's so easy. I can't believe it. I don't have to worry about it. I don't have to think about the database. I don't need to think about it. It's all out of the way, handled automatically. Thank you, Jeremy. It's so much better. Thank you. I'm glad you agree. And Hibernate allows us to relate our entities together so we can even do queries on multiple tables at the same time. And it's not any harder. None of it really requires any SQL, although it's still there if you need it. And as you can see, because I turned on show SQL in my application properties, it really is still happening. It's not like the SQL disappeared, just that it's generated now and I don't have to think about it. We don't have to think about it. Still there. Still important to know, as are JDBC templates from Java 3. But I think you agree, this is the better way. The better way. Okay, so, ladies and gentlemen, we're nearly done with database operations. But obviously, you can expect to see them in just about every lecture from now until the end of the course. I'm going to assume you're good with it. I'm going to assume you've got this. Not to mention the assignments and the exams. It's going to be on the assignments, one of which is coming out next week, if I remember. And also, it's going to be on the exam. I won't kill you. The pet kid example that is in our exercise is maybe tough enough, perhaps. I'll try to keep it easy. But I think you probably already know that it's tough to write meaningful systems without some fast form of storage. And I think given the possibilities that we have enabled yesterday, last class and today, the amazing possibilities we have brought into existence, if you will, with one-to-one and one-to-many and many-to-many perhaps, I don't know why you wouldn't want to. Anyway, why wouldn't you want to? So Dev, lazy eager, not on the midterm. Yeah, no worries. Relationships on the midterm. One-to-one, one-to-many. For sure. For sure. So, ladies and gentlemen, out there in the room, of which I think there are 20-something of you, 25 when we started the lecture. Maybe we lost some people, not sure. Thank you, as always, for your time and your attention and your energy. I hope it's been interesting. Peace out. Thanks, everybody. Cheers.